Want to learn some calculus? Where's the camera? I don't know. Oh, it's right there. Learning how to calculus. Well, have I got the stuff for you? This problem has sick g of x stuff and a little sprinkle of some f of t stuff too. And boy, howdy do I love all these curves. But I'm not really sure how this math adds up, so I'm gonna have to ask my magical science friend. Whoa, Dr. Janky, where'd you come from?
I was putting it down in Miami, Florida. You took away from my Coke, man.
Coca-Cola, right?
Well, I heard you had a calculus problem, Billy.
Yeah. Let's talk about that.
All right, you ready to learn some math? So this is our problem today. All right, this is what we're worrying about. G of x is equivalent to the integration of 6 to x, and with f of t. With f of t, we'll get to that in a minute. This is our graph. All right, this is equivalent to this. It's weird, we know, but we'll get to that. It's fine. All right, first problem. A. Find g prime of a. Now, you might be freaking out, going like, "Oh God, what? It's t though." It's easy. Trust me, it's easy. So first, you gotta find the prime. That means you gotta do a derivative. All right? And I know you know derivatives. That's an antiderivative. It's a derivative. It just cancels out. I'll even write it. I'll be nice. Let's say g of x prime. It goes from 6 to x. Because that means take a derivative, it just goes goodbye. It pieces out. It's done. But then I hear you freaking out. Oh, what about this f of t? There's no t on this here graph. That's where the fun stuff comes in. Because of complicated math and all that stuff. That t, it just gets replaced with x. So g prime of x will end up equaling f of x. Because f of x doesn't get a prime because we have the antiderivative, so it's just like that t, it's right here, it goes whoosh, bye-bye little t. Alright. And then what happens next? You got to plug in your x. So g of x, you got to go to 8. So you go over here to the 8 and you align the dots, it's 1. And it's easy. And it's so nice.
Huh?
Alright, I hear you asking about b now. B, that's fine. It's fine. It's all easy. As I wrote right here, it just appeared on the whiteboard. I don't know how it appeared on the whiteboard, but it happened on the whiteboard. B is effectively asking all values of x where g has a point of inflection. And I know you're going like, what's inflection? What's that? It's easy. It's good stuff. It's when sign changes from negative to positive, positive to negative, back and forth, it's fine, all right? So, I have a handy little problem up here, because I have dementia. I can't remember half this stuff. So, I'm going to look up here, all right? So, for point of inflection, that's when we get into the double prime stuff. Double prime stuff, it's weird stuff, but it's fine stuff. Because we know this is the graph of f of t, which is equivalent to the graph, get this, of g prime. That's a bad marker, but it's fine. Sorry, I got a bit too much fun with the Coke. It's fine. So this graph is equivalent to g prime. Now, we don't know much about whenever it gets to just graphs and stuff because we don't have a calculator for this. So we can't graph the double derivative of this. It's sort of okay. All right. So what we're gonna do is we're going to find when the sign changes from positive to negative to positive, or from Narnia to the sun. I don't know, but we're going to find it. So we look at the graph. Graph is nice. We have over here, I'm going to go on to this side because I like this side. It's going from positive, like it's looping upwards, whoop, and it's going from negative. So we mark one of these down. That's a -3, so we're going to write -3 right here. We're just going to mark that down. We're going to keep that on mind. Next up, we got another one. It's at 3 again. Could you believe it? I don't believe a lot of things. The moon landing's fake, but that's fine. It's up here. It's 3. So we're gonna mark down another 3. I think. Yeah.
It's 3.
And the next one. Another sign change because 3 is because upwards and then downwards because we're looking at the curvature. We're looking at how big of a curveball we're throwing. All right. And now we go to 6. It's coming downwards. It's going upwards. That's another sign change. It's 6. And we go is there any other ones? Short answer: no. We don't need to do the math on how we want to stuff. But that's it. And if, in fact, I'll even be nice. Go to Narnia. We're gonna write down here. Badoop, 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 badoop. This is 3. This is 6. This is -3. Over there, it's curving downwards. We got a negative. Then upwards, and it keeps going upwards till we hit 3. Then it goes back to being negative. It's sad. It's depressed. Then we get 6. It goes from negative being positive. That's a point of inflections. And it's lovely. The marker went goodbye, but we're not going to worry about that. All right. And this says reason for answer. I already gave you the reason. Just write. X equals -3. 3, 6. And these are all points of inflections because that's where the sign changes on the graph of f of x. F prime of x. No, just f of x, yeah. And that's how you solve it.
Wait a minute. Wait, I know this one, Teach. Is it this?
Actually, Jim, hang on. Wait a minute. That's actually right, Jim. You know, you know what? Just for that, you give the next part right, I'll give you a little more of this bag. Not this bit, though. This one's for me.
Well, I know I have to find the area, but I'm not sure about the formulas, Dr. Janky.
Oh, then you're an idiot. All right, Timothy, I know you're a little bit slow. You don't know your areas. You didn't pay attention to geometry. It's fine, all right? It's okay. We're gonna take this step by step, you idiot. All right, so what we have. I am all powerful. This graph says we gotta go from we gotta go from 6 to X. So think of this, that's where we start, you know. Alright, so we gotta take 2 areas. And I found everything like, oh God, no, I don't know how to do multiplication. Well, you're gonna do it anyway, you're gonna learn how to do it. We got it from here. This is gonna be our G to 6 because that's what it asked for. It asked from G to 0, not G to 6. It's asking for G to 0. Get that through your head, kiddo. So we're going from here to here. So we need to find the area of a circle. I know what you're thinking. You're like, oh, the area of a circle is pi r squared. And you'd be right. Except for one problem. You see this? It's a semicircle. We gotta divide it by 2. So, we gotta find our radius, and we can just do some counting. You passed 1st grade. You didn't pass 5th, though, so that's alright. So we're gonna go 1, 2, 3. That's our radius. So we're gonna plug it into this neat little formula. Pi 3 squared divided by 2. We're gonna do some math, and it's gonna be 9 pi over 2. We're gonna leave pi as a variable, because pi is dumb and stupid and dumb. But now I hear you asking, whoa, why is it negative, Professor Janky? And that's a great question. We're going from 6 to x, which means we gotta go this way. What happens when you go backwards? You're doing bad. You drive a car backwards, then you're crashing into another car. That's bad. So that means this becomes negative because we're actually going reverse in time. I know you don't understand time. What, you're like 40 years old and you still haven't got a proper job? It's fine. So what we're doing, ow, that hurt. What we're doing is it's going to be negative now. And now it's time for the easy one. You know your triangles. You know your Pythagorean theorem, sine, cosine, tangent. We don't got to worry about those ones. Thank God. So what we're going from here to here. So we need our base. Our base, 3. We need our height. And it's 6 to 12. Just do 12 minus 6 if you can't count. And it's 6. And we plug into 0.5 times 6 times 3, and all equals 9.
I'm so lost, Teach.
That's fine, Timothy. Geometry's weird. We don't like geometry. It's areas and triangles and circles. I don't want to worry about shapes. What we're gonna worry about is problem number D. All right? And I don't know how it appeared on the whiteboard again, but it's fine. I'm not gonna question it because it's asking us to find the value of x, where G gains an absolute minimum. But I hear you asking something. I hear you, little Jimmy Fee, and it's like, but this is the graph of G prime and f of t. If you want to be weird, but we're going to G of prime for this. All right, you idiot. We're going to like that. Sorry about that. My health's declining. You know how it gets. I might be dead soon. All right. So what we're gonna do? We know stuff because we're smart. Mostly. I don't know. We're probably smart. So, we're taking this. This is the graph of G of prime. And you're like, well, how do we know what our absolute minimums are when we can't plug it into a nice graphing calculator and get the original thing? Just go like, trace the thing. There it is. I'll tell you, we gotta find our zeros first. So first, we're gonna look up here. Zero right there. So I'll even write it down for you, little boy, because I know you're barely literate. So it's gonna be -6. Because we're going to have some more. Our next one, it's at 0 because, see, it's touching the x-axis. That means it's a 0. I know, it's hard to believe, but hey, it's fine. So we're going to write 0. And then another comma because we got one more. It's 6. We got another one at 6. And they're like, 6. And it's like, it's fine. We got our minimums now. No, you're wrong. Because you see these are liars. At least 2 of them are liars. It's like 2 lies and 1 truth. Like how the government is lying to you about the cheese tunnels. We'll get to that later. That's next lesson. So what we need to know. This is -6, this is 0, this is it. Now, for purposes like this, the graph still goes on from here and to there, but it stops at these points because it tells us -6 less than or equal to x, and then less than or equal to 12. It is giving us the parameters, but we know it's a lie because we know it keeps going because that's how graphs work most of the time. And this one it probably does. It's fine. So we need to look at our points. We're going to look at -6. Does -6 function as an actual point? That's a great question. It doesn't. Because it's not continuous. Because it just stops. It can go right here, but after here it just dies. It falls off the deep end. And it goes in, it becomes a YouTuber. It's the worst possible scenario. And then you see over here, 6. Oh, it looks continuous. It's got a line going to another line. It's fine. It's not fine. It's a cusp. A cusp? I don't remember why it's bad, but it's not good. It's not good. It looks like a little birdie. It's bad. So we go to our final one. We go to 0. It keeps going. It's not doing anything weird. And it's fine. So our absolute minimum is at 0. So, and because they're AP problemers, they're saying justify your answer. Why do we want to justify our answer? Because we want more points. Yay, go away. I need the blue marker. There is an absolute minimum at 0 because it's at 0. And there's a better explanation because f of x goes from negative to positive, which means that it crosses on the x-axis. Woo! So now you know how to make drugs, kiddos. That's fine. We don't gotta worry about that. It's alright.
This message was brought to you by Druggies Against Calculus. Hold up 1 second. What? They hit the Pentagon?